Welcome to HealthCast. I'm your host, Adam Patterson. We are joined today by Nikki Beitenman, a 3D printing specialist at the Charleston VA Medical Center. Nikki has played a foundational role in overseeing the establishment and growth of the Charleston VA's 3D printing initiative, which now stands as one of the most promising and innovative hubs within VA's broader 3D printing network. The Veterans Health Administration has quickly emerged as one of America's foremost centers of medical 3D printing research, having applied these capacities in areas ranging from prosthetics to complex surgical prep. Nikki has recently been overseeing the VA's Geostent Program, a 3D printing initiative designed to provide ear stents for patients that have suffered hearing loss due to rarer or more unusual conditions. Nikki, welcome to the program.
Thank you for having me.
Absolutely. And I wanted to start with kind of an overview question about yourself. As some background for our audience, what first inspired your interest in medical 3D printing, and what brought you to your current work at VA's Charleston Medical Center?
So I'm a biomedical engineer by background. I went to the University of Akron in Ohio, which is where I'm from. And I then took my first biomedical engineering job out of college at the St. Louis VA Medical Center, which was back in 2016. I had done a little bit of 3D printing in college, but mostly in college, you just learn to do the design work, and then you give your professor your file and they run it on the printer for you. So you don't really get to touch the printer that much. When I started in St. Louis, I spent a day shadowing the prosthetic department there. I was very interested in prosthetic work. I started talking to the prosthetist, and I was telling him how I wish I did a little more of his type of work, and he told me he wished he did a little more type of engineering work. And we kind of brainchild this idea of having a 3D printer and being able to help our amputee patients by either reducing turnaround times for them and also decreasing costs for them on things such as temporary sockets or assisted devices, anything we could pretty much do to just make their life better. So from there, the two of us put together a proposal. We got a first printer on site and we started doing temporary sockets. So the prosthetist would scan the patient. We would design in a CAD software the file and then throw it on the printer. And we can actually 3D print a socket in under an hour. So we could get them back to the patient either next day or in a day or two, depending on how many we had. So the current process of sending it out to a vendor would take several weeks to get that product back for the patient. And sometimes it wouldn't be perfect, so they'd have to make numerous trips back and forth. And by getting that printer on site, we reduced the cost down to just $6 to make the product. And we could tweak it right there on the site with the patient in front of us instead of having to do a bunch of return visits. So we really were able to show the benefit of having the 3D printer there. And then in 2019, my husband and myself decided we wanted a change of scenery. So we moved down to the coast. When we came to Charleston, there were actually no 3D printers here. I pitched to my supervisor that that's what I wanted to do and bring that technology to this facility. And I was able to get our first printer access from another VA. I knew of this printer through VA's 3D printing network. So I knew it was a very old printer and it had a very tiny print bed, but we took it anyways. And we made our first project here, which was a cup holder for a patient's wheelchair. So just for background, wheelchairs don't come standard with a cup holder on them. It has to be ordered specifically for each patient. The vendors actually charge us $87 for a cup holder, and it can take 4 to 6 weeks to get it, and it gets shipped to the patient's home, and then a caregiver has to put it on for the patient. So by having this printer on site, we can just make numerous cup holders, have them on hand. So when a patient comes in, we can just give it to them at their time of visit. And it also only costs us about $4 to make it. So the demonstration of what we could do with printing here justified us to get a newer, larger printer. And then in 2020, of course, COVID happened. So we were really able to show the benefits of having the printers for things like face shields. We made so many of the ear savers to get the mask straps off of the back of patients' ears, also for our staff here. So we've grown from just having that one little printer to now having over 20. And we also have a laser cutter, and we now also have dedicated staff running all this equipment. So basically, we have just expanded rapidly in the last 2 years.
Yeah, that sounds really serendipitous too. This initial investment and focus on expanding the 3D printing capacities at Charleston right leading into COVID sounds like it gave you a strong foundation for responding more effectively to the pandemic. I want to kind of back up a little bit though, because you'd mentioned it's been about 2 years coming at Charleston where you all have been working on 3D medical printing. But when did VA as a whole kind of begin exploring the application of 3D printing to medical services? When was the initial germination point for VA broadly?
So many VAs have actually been utilizing 3D printing for 10 to 15 years. A lot of them in the realm of assistive technology devices like PT/OT, any kind of rehab type situations, and then also really heavily in the research world. The VA formally established the 3D printing network in 2016 to bring sites together that were printing to really work on standardizing practices and also to share thoughts and files and things of that nature, try to make it easier for everyone so we're not repeating work and also sharing our work across the network, which is very beneficial. It's so nice to have an entire country of people to rely on. If you get stuck on something, or even if you have an idea and you need people to trial it for you, we can reach out across the network. So it's a very, very great thing that we have set up here and that we have going.
Absolutely. That is decidedly really impressive. And at this point in time, you said about how many hospitals throughout VA's network currently use 3D medical printing, would you say?
There's about 60 medical centers that have 3D printing technology, whether that means they just have one printer in one service that focuses on one type of application, or several facilities have multiple printers focusing on multiple different types of projects. In 2020, in the midst of COVID, we really learned the benefit of having these printers, like I mentioned. So VA launched the ADAPT initiative, which stands for Agile Design and Product Transformation. So we selected 3 sites to be established for the purpose of medical device manufacturing. This really stems from the COVID swabs that were being 3D printed. So those 3 sites were Seattle, Washington, Richmond, Virginia, and then us here in Charleston. So the benefit of these 3 sites is that we've established the quality management system for our processes, which enabled us to formally register ourselves with the FDA. So in doing so, we're able to actually manufacture medical devices and list them under our FDA registration.
That's really cool and sounds like a really effective way of seeding ingenuity and seeding development. And in light of that, I'm kind of curious, what do you think across VA as a whole and within Charleston where you're working at, what have been some of the most promising applications of 3D printing to patient care and surgical prep that you've seen so far?
So a big one that we see across the network is dental. And a huge benefit is, of course, the cost reduction and then the turnaround time. So being able to make things very quickly for patients, reducing the number of visits that they have to have, and being able to treat the patients faster and get them the care they need is a huge part of dental. And also another very popular one is anatomical modeling. So for pre-surgical planning, and we're able to do that by utilizing radiology imaging like a CT or an MRI. We take those imaging files, put them into a segmentation software, which is where we are able to kind of pluck out the anatomies we want to see more of. And then we can build the 3D model out of those anatomies we select, print them, or even just look at them virtually or in VR, and enable the surgeon to better plan out the surgery before ever putting the patient in the OR. And not only is that beneficial for the surgeon to kind of get a better idea of how they're going to attack a surgery, or really, even if they can do the surgery the way they want to, but that's also a powerful education tool for staff, such as residents who are learning along the way, or also for the patients themselves. So a lot of times the patients really don't understand what's going on, but if you can show them a physical model of what's happening internally, they can really better understand their own healthcare.
That's really cool and sounds like a way of better and more precisely delivering care in a way that's obviously, more patient centric. And I want to ask about something that you've been working on pretty closely because you just presented on the Geostent program at the recent IEX conference last month in October. And I'm kind of curious, can you tell us a bit about Geostent's origin, what it provides, and when it was first launched?
Sure. So last year, we were actually approached by an audiologist at our facility here in Charleston. So the audiology clinic sits right next to the eye clinic, and we have been doing a lot of 3D printing for the eye clinic, specifically for shielding for COVID purposes, of course, to kind of make some boundaries in between the caregiver and the patient. You know, for the eye clinic, they're so up close and personal with you. So getting a shield in between made the patients more comfortable, also made the caregivers more comfortable. So the audiologist, we had kind of talked to him. He's friends with one of the eye doctors, and we were explaining, you know, all the printers and things that we had. So the audiologist saw our patient, which you guys all saw highlighted, Mr. Nicoletti. He had been sticking drinking straws in his ears because he had a collapsed cartilage issue. So basically, if you looked at the outside of his ear, it looked like his ear was completely closed off. But if he pulled his ear back, it would open up his ear and then allow him to hear. So he wasn't a candidate for hearing aids because he didn't necessarily have a hearing issue. He had a cartilage issue, if that makes sense. So by opening up that cartilage, it allowed the sound waves to pass through. So of course he came into the audiologist and told him he was putting these drinking straws in his ears, which is every audiologist's nightmare. You know, there's concern that he's going to push it in too far and it's going to get stuck in there, or if he's going to, you know, puncture his eardrum, anything that could have gone wrong with these drinking straws. So Dr. Flanagan, who's the audiologist, had chatted me and said, hey, I think I have an idea of something we could 3D print. Are you guys willing to work with me? And we said, of course. So he had sent me a very cryptic little drawing that he sketched together in Microsoft Paint and was like, this is what I think I want to do. So we took that drawing and made it into a 3D shape. We initially scanned the patient's ear. They took a mold of his ear. We scanned the mold and we made a stent that was the exact shape of his ear. That was very difficult for the patient to insert. So we kind of went back to that straw idea and just made a tube, but put a flange on the end so he couldn't push it in too far. And then we also made sure we went through all the different biocompatibility tests we could find on the different materials available. We did a hard material, a soft material. We had to find something that was strong enough to hold open his cartilage, but also soft enough to be comfortable for him. So that was kind of we had to do numerous prototypes to go through and figure out what was going to work for him. We did numerous different shapes for him. And the patient is actually an engineer by background. So he was like the perfect patient to do this because he could tell us exactly what was going on and the tweaks he wanted us to make for him. So he was the sweetest, best candidate we ever could have had for a product like this. So ultimately it was great because the patient was completely involved with his care and really with designing his own device. So from there, once we kind of realized we were in medical device realm, we reached out to our network and went through the whole process with compassionate use to get approval from the FDA to allow this patient to continue to use it. And it's been great so far, and he's been a very happy camper. So we haven't had to make any changes since the final prototype, so things are going really well for him.
That's great, and a really inspiring story, because it sounds like, if I'm getting this correctly, one of the real benefits there in terms of 3D printing was it allowed you to create a prototype that was much, more closely mapped to the patient's physical dimensions of their ear, if I'm getting it right. And it sounds like in that instance, that was a founding case where you had it sounds like cartilage collapse that made it difficult for the patient to hear. What other conditions or rarer conditions have you been able to apply this Geostent model to in terms of providing patient care and hearing recovery?
So we have another case actually that we've been working on, and it's still technically a Geostent, but this patient is a little different in the sense that his cartilage isn't collapsed. However, his jaw is closing his ear off when he talks or chews, or any kind of movement on his jaw is closing off his ear. So now we're working on this case where it's, okay, Mr. Nicoletti still needed something soft, where this patient also needs something soft, but also kind of something hard to prevent that jawbone from hitting against the ear. So this is another case that we're kind of trying to tailor exactly to the patient-specific needs. So we're working through this with him to try to figure out how to solve this problem with a similar solution, but still something really tailored to this patient.
Absolutely. And something else I wanted to ask as kind of a closing question here is, do you see the Geostent program and this application of 3D printing to audiological conditions more broadly being expanded across the VA care network nationwide as a whole?
Absolutely. So we're going through all the processes right now for the Geostent to be expanded. It's currently only approved for Mr. Nicoletti. So that's what the compassionate use means, is it's only for his one condition for him right now. So we're going through all the steps to be able to expand this to any patient in a similar situation, and also try to get it to any VA medical center across the country. So our goal is by next year to have a tackle box per se of a bunch of different geostents, sizes, shapes, material options, so hard and soft. So if a patient walks into an audiology clinic, they can just be sized on the spot. If it fits, they can go home with it. So that's the end goal. So that's what we're trying to get to. We're going through everything in the quality management system to make sure we have all the testing complete, all the validations and qualifications on our equipment, on our materials, and making sure we have everything in line so that we're doing it appropriately in the eyes of the FDA to be able to expand this out for other patients to use.
Absolutely. Really building that foundation for scaling it, for getting the approval.
Yeah.
Before we wrap up, I want to ask, is there anything else you'd like our audience to know about the Geostent program? Any possible future cases you're looking into or projects we should keep an eye out for on the horizon?
Well, really the best thing about the Geostent project, the thing that we learned from this was the process of, okay, I made a 3D printed device. Now what do I do? Like, what's the right way to give this to the patient and make sure we're doing it safely, effectively, and for a cost savings, everything beneficial for the patient. So now that we kind of figured out that pathway and where to go with this, now we can take any kind of design or any 3D printed product and follow the same steps to be able to get any new item we want out to any patients. So really the benefit of this project wasn't necessarily just that project itself, but the fact that we now know the right pathway to follow for any project.
Absolutely. And it sounds like there's really only room for further growth and expanding this to provide help for patients that, may have had rare or difficult conditions and are now finally able to treat them. Wonderful, Nikki. Thank you so much for coming onto the program.
Thank you so much for having me.
HealthCast is a production of Government CIO Media and Research. For more podcasts, head to governmentciomedia.com/podcasts. HealthCast is produced by Amy Kluber, hosted by Melissa Harris and Adam Patterson. If you liked what you heard, let us know by leaving a review in iTunes or wherever you listen to podcasts. Thanks for listening.